Now we are going to take up first chapter of second term, carbon and its compounds. Carbon has atomic number 6. It has 2 electrons in the first shell and 4 electrons in the second shell. Fullerene is allotrope of carbon which has football-like shape. Now we are going to take up allotropes of carbon. There are 3 crystalline allotropes of carbon. The first one is graphite. You can observe it is grey color solid and it has got hexagonal layers, and these hexagonal layers are held together by weak van der Waals force of attraction. Diamond is a colorless and it has high brilliance, but in diamond each carbon is tetrahedrally linked with 4 carbon atoms and result in the formation of octahedral structure. The third allotrope is called Buckminster fullerene, and it has got soccer ball or football like shape, and each carbon is linked with 3 more carbon atoms, resulting in the formation of 5-membered and 6-membered rings, and overall the structure is football type. Now we are going to take up the differences between graphite and diamond. In graphite, each carbon is linked with 3 more other carbon atoms in the same plane, giving hexagonal arrangement and having 1 double bond. This double bond can also be called as van der Waals force of attraction because this is between the layers. Whereas in diamond, each carbon is linked with 4 carbon atoms which are very strong bond and very close to each other, and it gives rise to octahedral structure. The second difference between diamond and graphite is that graphite is soft and slippery. Why it is soft and slippery? Because there are weak van der Waals force of attraction between hexagonal layers, whereas diamond is the hardest substance known. It is hard and rigid due to strong carbon-carbon bond, and each carbon is linked with 4 carbon atoms, and these carbon atoms are quite close to each other. Third difference is that graphite is a good conductor of heat and electricity. Now why graphite is good conductor of heat and electricity? Because it has got free electrons. Each carbon is linked with 3 carbons, so 1 electron per atom is free. Whereas diamond is poor conductor of electricity or does not conduct electricity easily because each carbon is linked with 4 carbon atoms and no electrons are free. The fourth difference is that it is greyish solid and opaque in nature, whereas diamond is transparent and lustrous. Now we are going to take up differences between ionic and covalent compounds. Ionic compounds have high melting and boiling points. Examples are NaCl, melting point 1074 and boiling point is 1686 Kelvin. Lithium chloride has got 887 as melting point and 1600 is the boiling point. Calcium chloride 1045 Kelvin is the melting point and 1900 is the boiling point. Calcium oxide has 2850 Kelvin as melting point and 3120 Kelvin as a boiling point. Magnesium oxide has melting point 981 Kelvin and 1685 Kelvin is the boiling point. On the other hand, covalent compounds have low melting and boiling points. The first example is acetic acid. Acetic acid is present in vinegar. Formula is CH3COOH. Its melting point is 290 Kelvin and boiling point is 391 Kelvin. Chloroform has formula CHCl3. Its melting point is 209 Kelvin and boiling point 334 Kelvin. Ethanol is present in wines, beer and whiskey. Its formula is CH3CH2OH. Its melting point is 156 Kelvin and boiling point is 351 Kelvin. Methane is a gas which is present in natural gas and CNG, compressed natural gas. It has melting point 90 Kelvin and boiling point is 111 Kelvin. Methanoic acid, that is formic acid, has melting point 281.4 Kelvin and boiling point is 373.5 Kelvin. Second property of ionic compound is that they conduct electricity in aqueous solution as well as in molten state. whereas covalent compounds do not conduct electricity in aqueous solution as well as molten state. The third point is the force of attraction between the ions in ionic compounds are very strong, because these ions are oppositely charged, that is positive charge and negative charge, therefore they attract with strong electrostatic force of attraction, whereas force of attraction in covalent compound is quite weak. It is van der Waals force of attraction between the molecules. They do not have ions. The fourth difference between ionic and covalent compound is that all ionic compounds are solids. For example, sodium chloride, calcium chloride, lithium chloride, calcium oxide and magnesium oxides all are solid. Whereas covalent compound exist in all the three physical states, that is solids, liquid as well as gases. For example, glucose is solid, acetic acid, chloroform, ethanol are liquids, whereas methane is a gas. Fifth difference between the ionic and covalent compound is that most of the ionic compounds are soluble in water. Why they are soluble in water? Because ionic compounds form ions in aqueous solution, whereas most of the covalent compounds are insoluble in water. Why they are insoluble in water? Because they do not form ions in aqueous solution. Let's take up electron dot diagrams of covalent compounds. Covalent bond is formed by equal sharing of electrons. Covalent bond is of three types: single bond, double bond and triple bond. Let's take one by one. Hydrogen has one valence electron. It will share one electron with another hydrogen atom to become stable. So there is a single bond between hydrogen atom in hydrogen molecule. Chlorine has 7 valence electrons. It needs one more electron to become stable. So it can share one electron with another chlorine atom, and both of them will acquire 8 electrons in their outermost shell and become stable. So there is a single bond between two chlorine atoms in chlorine molecules. Let's take up example of oxygen. Oxygen has 6 valence electrons. It needs 2 more electrons to become stable. So it will share 2 electrons with another oxygen atom, and after sharing, both the oxygen atoms have their octet complete, that is 8 electrons in their outermost shell. This time double covalent bond has been formed between 2 oxygen atoms. Next example we are taking of nitrogen. Nitrogen has got 5 valence electrons. It needs 3 more valence electrons so as to become stable. It will share 3 electrons with another nitrogen atom so that its octet is complete. So after sharing 3 electrons, octet of both the nitrogen are complete, and this time triple covalent bond has been formed between 2 nitrogen atoms. Now we are going to take up formation of HCl. In HCl we have hydrogen atom which has got 1 valence electron and chlorine atom which has got 7 valence electrons. They share 1 electron each and result in the formation of single bond. So HCl has single covalent bond. If we take the case of water, in water central atom is oxygen which has got 6 valence electron. It shares 1 electron with 1 hydrogen atom and 1 electron with another hydrogen atom, and oxygen was having 6 electrons of its own. Now the octet of oxygen is complete, duplet of hydrogen is complete. Duplet means it needs 2 electrons to become stable. This is electron dot diagram of water in which there are 2 single bonds, and oxygen has got 2 lone pair of electrons. Lone pair means which do not take part in bond formation. Let's take the example of ammonia. In ammonia central atom is nitrogen. Nitrogen has 5 valence electrons. It needs 3 more electrons. 1 electron it shares with 1 hydrogen atom. Another electron it shares with another hydrogen atom. the third electron it shares with third hydrogen atom and results in the formation of 3 covalent bonds. One pair of electron is still left, which is called lone pair of electron. This is the electron dot structure of ammonia, and this is the bond structure of ammonia. Last we are taking electron dot diagram of methane. In methane, central atom is carbon. It shares one electron with one hydrogen atom, one electron with the second hydrogen atom, one electron with the third hydrogen atom, and one electron with the fourth hydrogen atom. So carbon now after sharing has 8 valence electron and has become stable, and each hydrogen has got 2 electrons after sharing and it has become stable. So carbon has formed 4 single bonds in methane and completed its octet. Let's take up electron dot structure of carbon dioxide. Carbon is the central atom. Carbon has 4 valence electrons. It needs 4 more electrons to become stable. It is sharing 2 electrons with this oxygen atom, so that octet of oxygen is complete because it has 6 valence electron and 2 it has shared. Now it has become 8. With this oxygen atom also it is sharing 2 electrons and octet of oxygen is complete. Carbon after sharing has 8 electrons, that is its octet is complete. So carbon forms double bond with this oxygen atom and double bond with this oxygen atom. Now we are going to take up electron dot diagram of sulfur. Sulfur is octaatomic molecule, that is S8 molecule. In sulfur, each sulfur is linked with single bond. So there are 8 sulfur atoms which are linked with each other by single bonds. And after forming single bonds, each sulfur has got 2 lone pair of electrons. Because sulfur was having 6 electrons, it has shared 1 electron with other sulfur atom and 1 electron with second sulfur atom on the other side, and total electrons after sharing have become 8. So each sulfur has its octet complete. Each sulfur is forming single bonds with 2 sulfur atoms and resulting in the formation of S8 molecules, which has crown like structure or puckered ring structure. Now we are going to take up saturated hydrocarbons. Saturated hydrocarbons are those in which valency of carbon is satisfied by single bond. The first saturated hydrocarbons we are taking ethane. The formula for ethane is C2H6. That is, there are 2 carbon atoms joined together by single bond. Each carbon has valency 4, which is called tetravalency. Carbon is attached with 3 hydrogen atoms. This carbon is also attached with 3 hydrogen atoms. If you are asked how many covalent bonds are present in ethane, the correct answer is 7 covalent bonds are present in ethane. When you want to make electron dot diagram of ethane, convert each single bond with 2 electrons, because every bond, single bond particularly, is formed by 2 electrons. So we have converted each bond by 2 electrons and we have got this electron dot structure of ethane molecule. Now we come to unsaturated hydrocarbons. Unsaturated hydrocarbons are those which have either double bond or triple bond. The first example we are taking is ethene molecule. In ethene molecule there is one double bond between carbon and carbon, and each carbon are linked with 2 hydrogen atom, so that valency of each carbon becomes 4. To make electron dot diagram of ethene, again replace each single bond by 2 electrons and double bond by 4 electrons. So this will be the electron dot structure of ethene. Here you will find that each carbon has got its octet complete and each hydrogen has got 2 electrons after sharing, and it becomes stable. Another unsaturated hydrocarbon is ethyne. Ethine has triple bond. That is, there is a triple bond between two carbon atoms. Valency of carbon is 4, so it will form one single bond with one hydrogen, one single bond with another hydrogen. To make electron dot diagram of ethine, convert this triple bond into 6 electrons, because each bond is formed by 2 electrons, and single bond between carbon and hydrogen replaced by 2 electrons, and this single bond between carbon and hydrogen also replaced by 2 electrons. Now check, each carbon has got its octet complete, and both the hydrogen has got 2 electrons after sharing, and they are stable. Let's take up hydrocarbons. Hydrocarbons are compounds of carbon and hydrogen only. These are 3 series of hydrocarbons, and these series are called homologous series. Homologous series is the series of organic compounds which have same functional group, similar chemical properties, and gradation in physical properties. First homologous series we are taking is alkanes. Every homologous series will have general formula. The general formula of alkane is CnH2n plus 2, where n is number of carbon atoms. If we put n is equal to 1, the formula comes out to be CH4. The name of CH4 is methane. ANE is the suffix followed in this family. Second member you will get when you will put n is equal to 2. If you put n is equal to 2, you will get C2H6. For structural formula of C2H6, we will write 2 carbon atom by single bond, and each carbon will be attached with 3 hydrogen atoms, so that valency of carbon is satisfied, that is equal to 4. The name of this compound is ethane. Ethane means there are 2 carbon atoms, ane means it is saturated hydrocarbon. Third example is propane. Here we are putting n is equal to 3. The formula will be C3H8. We will be writing 3 carbon atom in straight chain joined by single bonds. This carbon, 1 valency is satisfied, we will put 3 hydrogen. This carbon, 2 valencies are satisfied by single bond, we have put 2 hydrogen. This carbon has 1 valency satisfied, so we have put 3 hydrogen. The name of this compound is propane, and here also the suffix A and E is being used. Fourth member formula will be C4H10. Here we have written 4 carbon atom in straight chain. First carbon has 1 valency satisfied, so it will be CH3. Here 2 valencies are satisfied, CH2. Here 2 valencies are satisfied, CH2. Here 1 valency is satisfied, so CH3. This compound is called butane. 4 carbon atom will be called as butane. For 5 carbon atom, in the same manner we have written the formula C5H12, and this compound is called pentane. Pentane. Pentane is the name of this compound, and it has 5 carbon atoms. Similarly, if you try out 6 carbon atom, it will be C6H14. Write the structural formula in the same manner, and the name will be hexane. Now we are taking the next family, alkenes. Alkenes has general formula CnH2n. Here we don't put n is equal to 1, because double bond is not possible between single carbon atom. So we start with C2. C2H4 will be the simplest member of this family, and the IUPAC name, that is international name of this compound, is ethene. ENE is the suffix followed in this family. Let's take up second member of alkene family. Its formula is C3H6. Structural formula will be CH3 single bond CH double bond CH2, so that valency of each carbon is equal to 4. There are 3 carbon atoms, therefore this compound is named as propene. ENE is the suffix which will be used in this family. With 4 carbon atoms, the formula is C4H8. The structural formula will be CH3, CH2, CH double bond CH2. This compound is named as butene, Butene. With 5 carbon atom, we have structural formula given here, CH3, CH2, CH2, CH double bond CH2. This compound is called pentene. Alkene with 6 carbon atom, C6H12, has a formula CH3, CH2, 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 CH double bond CH2. It is called hexene. Now we take up next family, alkynes. The general formula for alkyne is CnH2n-2. This also we start with second carbon atom, that is 2 carbon atoms, because triple bond requires minimum 2 carbon atoms. The formula of first member will be C2H2, that is there is triple bond between 2 hydrogen atoms, 2 carbon atoms. Each carbon is linked with hydrogen atom, and the first member is called ethyne. In this family, Y and E will be the suffix which is used. Next member is C3H4, CH3 single bond C triple bond CH. This compound is named as propyne. Next member C4H6, CH3 CH2 C triple bond CH. This is called butane. With 5 carbon atoms, the formula is C5H8. CH3, CH2, CH2, C triple bond CH. This is called pentyne. Next member CH3, CH2, CH2, C triple bond CH. This is also having 5 carbon atom. So if we make 6 carbon atom, this will be named as hexyne. So it has CH3, CH2, 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 C triple bond CH is called hexyne. Let's take up isomerism. Isomers are those compounds which have same molecular formula but different structural formula. First we are taking isomers of C4H10. We are writing 4 carbon atom in straight chain. Each carbon is linked with First carbon is linked with 3 hydrogen atoms, so that its valency is 4. Second carbon is linked with 2 hydrogen atoms, because 2 valency was already satisfied. Third carbon is also linked with 2 hydrogen, and last carbon is attached with 3 hydrogen because 1 valency was satisfied. This is butane. Common name or trivial name of this compound is normal butane. Normal butane means it is a straight chain compound. Now we are going to take a branch chain. For branching, we write 3 carbon atom in straight chain and 1 carbon in branch. Put hydrogen in such a manner that each carbon has got valency 4. Now we want to name this compound. First we count 1, 2, 3. With the second carbon, this group is attached. This group is CH3. The name of the group CH3 is methyl. So this compound is called 2-methyl. Why it is called 2-methyl? Because methyl group is attached with second carbon. Now we see how many carbon we have counted. 3 carbon we have counted, so we call it propane. 2-methyl propane is the IUPAC name of this compound. So the butane has 2 isomers, one is straight chain, another is branch chain. In the same manner, let's take isomers of C5H12. The first one we have made straight chain. This is called pentane. Common name is normal pentane, and normal pentane means that it is straight chain hydrocarbon. Next we have taken branch chain. 4 carbon atom we have written in straight chain and 1 carbon we have written in branch chain. Now you have to put hydrogen in such a manner that each carbon has got valency 4. For naming of this compound, we count from this side. 1, 2, 3, 4. On the second carbon, methyl group is attached. So it is called 2-methyl. And total carbon atom we have counted is 4. So for 4 carbon atom we will write butane. Third isomer of C5H12 is also possible. Here we have written 3 carbon atom in straight chain and 2 carbon atom in branch. And valency of each carbon we have made 4. To name this compound we start counting 1, 2, 3. Now we write 2, 2. Why we are writing 2, 2? Because there are 2 methyl groups which are attached to the second carbon atom. Because there are 2 methyl groups, so we will write di. And what are attached with the second carbon? They are methyl group. So we are writing 2,2-dimethyl. 3 carbon atom we have counted, so we call it 2,2-dimethyl propane. This is the IUPAC name of third isomer of pentane. Now carbon can form straight chain compounds, carbon can form branch chain compounds, carbon can also form closed chain compound. This is the example of closed chain hydrocarbons, where we have taken 6 carbon atom in a closed chain. All the 6 carbon atoms are joined by single bonds. Now each carbon has got 2 valency satisfied, therefore each carbon is joined with 2 hydrogen. So this compound has 6 carbon atom and it is cyclic, therefore we name it as cyclohexane. Why we call it cyclo? Because it is cyclic. Why we call it hexane? Because total carbon atoms are 6. Another example of closed chain unsaturated compound we are taking is benzene. Benzene also has 6 carbon atom in closed chain. But there is a difference. There are alternate double bonds and single bonds. So we have 6 carbon atom in which there are 3 double bonds and 3 single bonds. Each carbon 3 valency is already satisfied. So each carbon is attached with 1 hydrogen. Name of this compound is called benzene. Benzene is unsaturated because there are 3 double bonds present in it.
Sir, can you tell me where iso and neo terms are used in above two?
Yes, in common names, when we have 2,2-dimethyl propane, that is 1 carbon atom is attached to 4 more carbon atom, the common name becomes neopentane. And we also use iso word in common whenever there is branch chain like this compound has got common name isopentane. In the same manner, this branch chain has got common name isobutane. Here we take total number of carbon atoms. Since total number of carbon atoms are 4, that's why we call it isobutane. Here total number of carbon atom are 5, we call it isopentane. Here total number of carbon atom is 5, we call it neopentane. Now we are going to take up some functional group present in organic compounds. The first functional group which we are taking is halogens. Halogens can be chlorine, bromine, fluorine and iodine. They are called chloro or bromo, fluoro, iodo. It is called heteroatom because this atom is present in the organic compound, whereas it gives distinct property to the carbon compounds. So the first functional group we have taken is halogens, in which we have got chlorine, bromine, iodine and fluorine, and they substitute hydrogen atom in hydrocarbon. Oxygen containing heteroatoms or functional groups are alcohols. The first is alcohol, in which OH group is the functional group. So in all alcohols OH group will be present, and this functional group decides the chemical properties of the compounds. Second functional group we are taking is aldehyde. Aldehyde, we have got carbon attached with a double bond, and with hydrogen there is single bond. So that is CHO is a aldehyde functional group. Ketone has carbon attached to a double bond and its 2 valencies are free, which will be linked to 2 carbon atoms at least. Carboxylic acid, a functional group C double bond OH, that is COOH is the functional group present in carboxylic acids. Now we are going to take up nomenclature of these functional groups. Nomenclature means naming of these functional group. First we are taking halogens. For halogens we only use prefix. Prefix means they will be in the beginning of the name. Chloro, bromo, fluoro, iodo, etc. For example, the first example contains 3 carbon atom and there is chlorine atom attached to the carbon atom. So this compound will be called as chloropropane. We can also call it 1-chloropropane because the carbon atom which is attached to chlorine will be given as number 1. Same way, the next compound contains 3 carbon atom and bromine atom. Therefore, its name is 1-bromopropane. It can also be called as bromopropane. The second functional group we are taking is alcohol. In alcohol, suffix is used. Suffix means it will be at the end of the name. And for alcohol, the suffix is OL. First example, we have taken 3 carbon atom which are attached with hydrogen and so as to make the valency of each carbon 4. And OH is the functional group which is attached to the first carbon. So this compound is named as propanol. The best way of naming this compound is 1-propanol because the OH group is attached to first carbon atom. Aldehyde has got suffix AL. It should be written very clearly AL and it should not look like OL. The example which we are given, there are 3 carbon atoms in which aldehyde group is present as a first carbon and we have 2 more carbon atoms. Total 3 carbon atoms are present and this compound is named as propanol. Why we call it propanol? Because prop is 3 carbon atom and propane, remove E and put Al, it becomes propanol. In ketone, the suffix used is ONE and we have got a ketone with 3 carbon atom. Ketone will always be in middle. It cannot be at first carbon, it can be at second carbon. So the first ketone contains 3 carbon atom and keto group is at second carbon. Keto group means carbon is attached to double bond with oxygen. This compound will be named as propanone. ONE is the suffix, propane is the basic compound, so propane you have to remove E and put ONE. Carboxylic acid, the suffix is oic acid. The example which we have taken is 3 carbon atom with carboxylic acid as a functional group. Total carbon atom are 3, we will call it propane. Again remove E and put OIC, that is propanoic acid is the name of this compound. Now whenever double bond is present, the class of compound is alkene and double bond is the functional group. And whenever you have alkene, the suffix used is ENE. For example, the compound which we have taken has got 3 carbon atom and which has got double bond after first carbon. So this compound is named as propene. Last example of functional group is triple bond. Whenever there is triple bond, the class of compound is called alkyne and in alkyne suffix used is YNE. For example, the example which we have taken contains 3 carbon atom and triple bond is after first carbon atom. Total carbon atom are 3, so it is named as propyne. Let's take up naming of alcohols. The first member is CH3OH. OH is functional group. Because there is 1 carbon atom, this compound is called methanol. OL is the suffix used in this family. Second member is C2H5OH, whose structural formula is CH3CH2OH. The name of this compound is ethanol. The third member is C3H7OH. Structural formula is CH3CH2CH2OH. The name is propanol. Propane because there are 3 carbon atoms. All we have written because there is OH group. Fourth member contains 4 carbon atom and the name of this compound is butanol. These are first 4 members of alcohol family. If you take molecular weight, methanol molecular weight is 32. Ethanol has molecular weight 46. Difference between 2 successive homologs is 14. The next member has molecular weight 60. The difference is again 14. and the last member has got molecular weight 74. The difference is 14. So each successive member of homologous series differs by 1 carbon atom and 2 hydrogen atoms, and in terms of mass it differs by 14 U. The next family we are going to take is aldehyde. The general formula is CnH2n plus 1 CHO. General formula of alcohol was CnH2n plus 1 OH, and OH was the functional group. Here functional group is CHO. Here we start with N is equal to 0 because 1 carbon is already there in the functional group. So the first member we get is HCHO. This compound is called methanol. If you want to write structural formula, this will be the structural formula of aldehyde group. Second member has 2 carbon atom, we call it ethanol. In this family, Al is the suffix which is followed. The third member contains 3 carbon atom and its IUPAC name is propanol. Fourth member has 4 carbon atom and its IUPAC name is butanol. Let's come to next family of ketones. Ketones, the functional group is C double bond O. This side we have CnH2n plus 1. This side also we have CnH2n plus 1. We can put N both sides same or different. Minimum number of carbon atoms in ketone will be 3 because 1 carbon will be this side, 1 carbon will be this side, and ketone will always be in between. It cannot be at the corner. So first member contains 3 carbon atoms. Therefore the name of this compound is propanone. ONE is the suffix used in this family. Next compound is ketone where 4 carbon atom is present, and this is called butanone. Next member has 5 carbon atoms, 1, 2, 3, 4, 5. This compound is known as 2-pentanone. Why do we call it 2-pentanone? Because ketone group is attached with second carbon atom. Next member has got 1, 2, 3, 4, 5, 6 carbon atom. So this compound is called 2-hexanone. 2-hexanone means that second carbon has got ketone. Why we have not mentioned here 2-propanone or 2-butanone? Because here 3-butanone or 3-propanone are not possible. Only 2-propanone is possible, which can be simply written as propanone. 2-butanone only is possible, which can be written as butanone. But in these two cases, 3-pentanone and 3-hexanone are also possible. That is why we should mention 2-pentanone and 2-hexanone. The next family we are taking is carboxylic acid. The general formula is CnH2n plus 1 COOH. The functional group is C double bond O and OH. First member again we get containing 1 carbon atom, and the IUPAC name of this compound is methanoic acid. Its common name is very popular, it is called formic acid, and it is injected by red ants and the insects. We cause irritation when ants bite us or any insect stings. The sting of ants contain methanoic acid and it causes irritation. The second member contains 2 carbon atoms. It is called ethanoic acid. Popularly it is called acetic acid, and 5 to 8% solution of acetic acid is present in vinegar. With 3 carbon atom, carboxylic acid is named as propanoic acid. Why propanoic acid? Because it contains 3 carbon atom, and oic acid is the suffix used in this family. Last member has 4 carbon atoms and it is named as butanoic acid. Butanoic acid contains 4 carbon atoms and carboxylic acid, therefore suffix used is oic acid. Let's take up reaction of organic compound. First reaction we are taking is combustion. Methane is undergoing combustion. In the presence of oxygen we are getting carbon dioxide and water. Heat and light is also produced in this reaction. Saturated hydrocarbons burn with blue flame. because they have higher percentage of hydrogen and less percentage of carbon. On the other hand, unsaturated hydrocarbon burn with smoky flame or sooty flame because they contains higher percentage of carbon and lesser percentage of hydrogen, and hydrogen is highly combustible. If you want to differentiate between methane and ethene or ethane and ethene, that is saturated hydrocarbon and unsaturated hydrocarbon, we can use test for unsaturation, that is bromine water test. Saturated hydrocarbons do not react with bromine water, whereas unsaturated hydrocarbon decolorize bromine water. Next we are taking combustion of ethyl alcohol. Ethyl alcohol will also burn with blue flame or clean flame, and it will also form carbon dioxide and water. Along with heat and light will be produced. Both these reactions are combustion reactions. Next reaction we are going to take up oxidation. Oxidation means addition of oxygen or removal of hydrogen. Here alkaline KMnO4 is acting as oxidizing agent. Instead of alkaline KMnO4 we can also use acidified potassium dichromate, that is K2Cr2O7 and concentrated sulfuric acid. Ethanol on oxidation with alkaline KMnO4 will get oxidized to ethanoic acid. So oxygen is being added, therefore this reaction is called oxidation reaction, and alkaline KMnO4 is supplying this oxygen, that is why it acts as oxidizing agent. Next important reaction we are going to take up is addition reaction. Addition reaction is the characteristic reaction of unsaturated hydrocarbons. Unsaturated hydrocarbon means which have double bond or triple bond. In this unsaturated hydrocarbons we are adding hydrogen atoms, and nickel is used as catalyst, and the product formed is saturated hydrocarbons because it has single bond. This reaction is also called hydrogenation because hydrogen is being added. This reaction has got application that it is used to convert vegetable oils to vegetable ghee. Vegetable oils has lot of double bonds which react with hydrogen in the presence of nickel and form vegetable ghee which is saturated. Next reaction is substitution reaction. Substitution reaction is the characteristic reactions of saturated hydrocarbons. Methane is the example of saturated hydrocarbon. It is reacting with chlorine in presence of sunlight. One hydrogen atom of methane is being replaced by Cl, and the product formed is chloromethane plus HCl is formed. Means one atom is being substituted by other atom, therefore this is called substitution reaction. Now we are going to take reaction of alcohol with sodium metal. CH3 CH2OH is ethyl alcohol. We are reacting it with sodium metal. We will get sodium salt of alcohol. The name of this compound is sodium ethoxide plus hydrogen gas is formed. This reaction also shows that alcohols are acidic in nature because acid react with sodium metal to liberate hydrogen gas. The last reaction in this sequence is dehydration of alcohol. Dehydration means removal of water. Here concentrated sulfuric acid is acting as dehydrating agent, and we need to heat. OH from this carbon and H from this carbon will be removed, and when we remove water, double bond will be formed between CH2 and CH2. The name of the product formed is ethene. Because water is being eliminated from alcohol to form ethene, that is why this is called dehydration reaction. Let's take up esterification. In esterification, carboxylic acid, for example acetic acid, reacts with ethyl alcohol in presence of concentrated sulfuric acid, which acts as a dehydrating agent and result in the formation of pleasant fruity smelling compounds called ester. This compound formed is ester ethyl ethanoate, and these esters are pleasant fruity smelling. They are used in cold drinks, ice creams as well as perfumes. In this reaction what happens, OH from acid and H from alcohol is removed. Water is removed and esters are formed. It can be used as a test for carboxylic acid if we add alcohol into it and concentrated sulfuric acid. It also can be used as a test for ethyl alcohol. You have to add carboxylic acid in presence of concentrated sulfuric acid, and pleasant fruity smelling compound esters will be formed. Next reaction is opposite to that. This is called saponification, and saponification is the process which is used for formation of soaps. In this reaction we take ester, and ester is reacted with alkali, that is sodium hydroxide. To understand this reaction, you can break the bond here, put Na here and OH here. So you will get sodium salt of acid, that is sodium ethanoate will be formed, plus ethyl alcohol will be formed. So in saponification, esters react with sodium hydroxide and result in the formation of sodium salt of acid plus ethyl alcohol is formed. Next we are taking neutralization reaction of acetic acid. Acetic acid will react with sodium hydroxide and will form salt sodium acetate plus water. This reaction is neutralization reaction of acid. If you want to distinguish between carboxylic acid and alcohol, so there is a test. This test is, we can react acid with sodium hydrogen carbonate and we will get brisk effervescence due to carbon dioxide. Brisk effervescence will be evolved and carbon dioxide will be evolved. How do we know whether carbon dioxide is evolved or not? We will pass this gas through lime water, and if lime water turns milky, that proves that carbon dioxide is being evolved. Another test you can use, carbon dioxide will extinguish the candle if you bring near it. Acetic acid also reacts with sodium carbonate. With sodium carbonate, similar reaction takes place and it results in the formation of sodium acetate plus water plus carbon dioxide will be formed. This is the reaction of carboxylic acid which react with sodium bicarbonate, that is sodium hydrogen carbonate or sodium carbonate, and brisk effervescence due to carbon dioxide is formed. Now we are going to take up cleaning action of soaps and detergents and how micelles are formed. Now you can observe the soap and detergents have two parts. Their head is hydrophilic. Hydrophilic means water loving, and their tail is hydrophobic. Hydrophobic means which has water hating, that is, it is not attracted by water. See, in the first diagram, grease and dirt is being surrounded by soap and detergents molecules, but molecules are little far away. In second diagram, these molecules are coming closer to the dirt and grease. In third, if you see that these soap and detergents molecules have surrounded the dirt and grease. In fourth diagram, they have completely surrounded the dirt and grease, and you can observe that micelles are being formed, and these micelles means aggregated molecules of soaps and detergents. All the tails which are hydrophobic in nature have surrounded the dirt and grease, whereas head, which is the ionic part or hydrophilic part, will attract water. Ultimately the water is attracted by hydrophilic part, that is their head, and dirt and grease is washed away with the help of water. Now we are going to take up difference between soaps and detergents. Soaps are sodium or potassium salts of higher fatty acids. Higher fatty acids means which they have high molecular weight, whereas detergents are sodium and potassium salts of sulfonic acid. These sulfonic acids may be of benzene or unsaturated hydrocarbons like alkenes. The second difference is that the soaps have got functional group COONA group, whereas detergents have got the group SO3Na. It can also have SO4Na. The soaps do not work well with hard water. Why they do not work well with hard water? Because hard water contains calcium ion and magnesium ion, which reacts with sodium salt of fatty acids and result in the formation of calcium and magnesium salts of fatty acids. these calcium and magnesium salts are insoluble in water and our soap goes waste and enough lather is not formed. Whereas detergent can work very well even with hot water. The reason is that calcium ion and magnesium ion react with sulfonic acid and these salts formed are soluble in water. Next difference is that soaps are 100% biodegradable, are fully biodegradable, means they are decomposed by microorganisms present in sewage and do not create any water pollution. Whereas some of the detergents which have branch chain hydrocarbon, that is branch chain alkyl group, they do not decompose by microorganisms present in sewage, so they create water pollution. Now the soaps do not work well with woolen garments. Why they don't work with woolen garments? Because woolen garments have acidic dyes and soaps are basic in nature, so they will spoil the woolen garments, their texture and color will be spoiled. Whereas detergents are very much suitable for woolen garments because they are acidic in nature and they do not react with acidic dyes and their texture also remains the same. Now some soaps may cause irritation to the skin. Some of the skins are sensitive to the basic compounds and soaps are basic in nature, so they may cause irritation to the skin. Whereas detergents do not cause any irritation to the skin. They are mildly basic or slightly salts of acid, that's why they do not cause any irritation. They take time. Soap will take time to dissolve in water. That's why we normally use hot water for washing clothes with the soap. Whereas detergents dissolve very easily and they are more effective cleaning agent. Examples of soaps are sodium stearate and sodium palmitate. Whereas examples of detergents are sodium lauryl sulfate and sodium 2-decyl benzene sulfonate.